We'll proceed in tedious calculus problems. Tedious calculus problem. Idea is not to solve any problem rather than to make people understand that why we need calculus. From simple example, then why we land up in calculating, in coming, why we land up in using calculus, why we need calculus. Okay, we can do anything, we can do any calculation with simple numerical science also. If numerical science is little bit difficult, it needs variable kind of thing, then we can use algebra. But why we need calculus? Calculus is also algebra only, right? Then why we need calculus? So we started with a past video. We tried calculating the length of a line. Okay, calculate the length of a line. What is the line? Line is y equal to x. That is a line. Line is y equal to x square. That is a curve. Y equal to x square. That is a curve. If this is x-axis, if this is x-axis, then this is origin. Then this is x square. See, like this. So this is x. If this is x square, this is x-axis. So if I move along x-axis, y, it moves, it goes up drastically. What is the length of this curve from point this, that is any point x1 to origin, or any point x2 to point x1? This is x1, this is x-axis, then and this is y-axis. Perpendicular is y-axis. This is two-dimensional problem. Now this is x1, this is x1, and this is x2, and this is x2 point. What is the length of this curve from here to here? That is the question. Now, okay, so looks like this is difficult, but how we can solve it? Consider there is a straight line. There is a straight line. Consider there is a straight line, and this is there is a straight line, and this is x-axis. This is x-axis. This is a straight line. What is the length of this line when x equal to 2? When x equal to 2, it go and hit here. What is the length of line between x equal to 2 comma y, whatever is the y, and origin? So I say the equation of, or let's start from the beginning. What is the length of a line from origin 0 comma 0 to a point called 4 comma 4? To point called 4 comma 4 and 0 comma 0. That's it. Okay, if that is the scenario, then it is straightforward Pythagoras theorem. This is numerical science. This is numerical science. Now, what is the length of a kind of line? Line equation is y equal to x. Line equation is y equal to x, and then point origin to point 3 comma 3 on the line y equal to x. I would rephrase it. Consider there is a line called y equal to x. There is a line. There is a line called y equal to x, and at any point x1 there is a point called y. Any point x or any point x, there is a point called y. This point is actually x comma y. What is the length of this line from point origin to point x? Equation of the line is y equal to, consider y equal to 4x. The equation of the line is y equal to 4x. What is the length of the line between x equal to 0 and x equal to x? Any x. Any x. Now, from the, if you see the previous question, that was from origin 0 comma 0 to 4 comma 4, direct Pythagoras theorem. Now line equation is y equal to 4x from x equal to 0 to x equal to 4. I cannot use Pythagoras theorem directly. It is now landing up into variable science, that is algebra. Okay, but still, We have described this in past video. So how to find a line length along a line is to find the vector along the line. This is what we saw. How to find the line length is if I use Pythagoras theorem, then from 0, comma 0 to 4, comma 4, that is 4 minus 0 whole square plus 4 minus 0 whole square, a square root, that is the length. If my line equation is y equal to 4x, from x equal to 0 to x equal to any x, x1, x2, whatever, what is the length of this line section? How to find it? Then what method we kind of invented, that is get the vector along this line. Once you get vector along this line, then then try to get a vector along this line and try to get magnitude of the vector. Try to get magnitude of the vector, you will get the line length. Okay, what is the vector along this line? Okay, if this is x and this point is x comma y, then this vector is xi. This point is x comma y. We are trying to find distance from x equal to 0 to x equal to x. If it is x equal to x, if I take up this point is y, this point is x comma y. This vector is from 0 comma 0 to x comma y is xi plus yj. What is the magnitude of this vector, that is xi plus yj? You get the length of the line segment between 0 and x, that is x square plus y square root. Or there is other fundamental also. Other fundamental is that try to get a vector, try to get a vector, try to get a vector along this line where x equal to 1. X equal to 1. For sure x equal to 1. If that is true, then the vector equation will be I, because x equal to 1. Xi plus yj is the vector equation from the origin. X is 1, then it is I, plus y will be y by x, j. Makes sense? If I am trying to find the line length of a line that is from origin to x equal to x, this point is x comma y. Rather than x, I take any point 1. From 1, what is this height? This height is same as, if this is x, then height is y. Then if it is 1, then height is y by x. Then the vector equation, it will be I plus y by xj. Whatever is the length, multiply it by x. Makes sense? Or people would be clever enough to say that your original vector was xi plus yj, right? It is passing x comma y. You want the curve length up till x, xi plus yj. Take x out. Take x out. It becomes I plus y by xj. Take any vector with x-axis is 1, then y-axis will be y by x. Then it will be I plus y by xj. Multiply it by x. Makes sense? Both are same thing. Okay, so if I know a line that is y equal to 4x, y equal to 4x is a line. What is the length of the line section from origin x equal to 0 to x equal to x? X equal to x, if I go up, it hits the line at point x comma y. From that point and origin, draw a vector. That vector will be xi plus yj. Take x out. I plus y by xj means if I have a vector form which has x component as 1, then y component will be y by x. Okay, then take the magnitude of it, multiply it by x, then it will be same distance. It is same vector. Xi plus yj is same as x, and in bracket I plus y by xj. Now the magnitude of original vector is xi plus yj is x square plus y square square root. Then here the magnitude of this vector is, keep x out, and then 1 square plus y square by x square square root. Why you are doing this much? Just take xi plus yj. Why? What is x? Take out and then I plus y by xj. What is this? This is okay. Anyway, understood. Understood. Why we are doing this one? Now just substitute whatever you want. Okay. Then if my vector is xi plus yj, the magnitude of this vector The magnitude of this vector is x square plus y square root. Okay, when x is 2, when x is 2, then what is y? Question is y equal to 4x. 8 square, 2 square plus 8 square root, that will be distance. Okay, now if the curve equation is y equal to x square, y equal to x square, that is the equation of the curve. Y equal to x square. Now I take any point x comma y on this curve, y equal to x square. Then distance from origin will be as per the formula now. It is xi plus yj. Then it is x square plus y square root. This is x square plus y square root. That will be the distance, the way we are calculating. Now x square, y is 2x, 4 square x square root. It will be square root of 5x. That is the curve length. Is it really true? My question is it really true? It is certainly not true. We described in the last video also. If I have if I have x-axis and I have a line and I'm trying to find along the line, I'm trying to find the length of the line where x equal to 0 on x-axis, x equal to x. In that sense, x will go up and it will cut here. X will go up and it will cut here. This point is x comma y. The length of the line is the vector form of this line, the magnitude. If this is x comma y, the vector form is xi plus yj. Magnitude is x square plus y square root. That is the magnitude. So that is the net length of the line. That is exactly true. Okay, but what about I have a equation of a line curve, that is y equal to x square. What is the length of this curve from origin and x equal to x? If x equal to x, then y is here. This point is x comma y. As per for fundamental, what would be the vector form of this? Vector form of this will be xi plus yj. That is also called position vector. And then x square plus y square root. That will be the length. But you are trying to find a straight line length, not the curve length. Curve length is this, not the if you are lucky, if someone is lucky and your line happen to be a straight line, then it is all right. X square plus y square root. What is y? Depend upon the algebra. Y equal to 4x, then it becomes 16x square. X square plus 16x square, it becomes square root of 17x. That is the length of the line from x equal to 0 to x equal to 8, that line segment. Okay, if that is the scenario, then what about this curve length? Oh, I made a mistake. I did not think that it will be a curve. I always thought that it is a straight line. Then I can take out the vector and calculate the magnitude. Okay, now try to understand what I am saying now. So your line, if you have position vector p, that is xi plus yj, I take any point x comma y, and to that I was trying to understand the length. Mind it, we started from origin to 4 comma 4. That is pure numeric. Then we started calculating the line where section where 0 to x. Then xi plus yj came. Now we are moving to algebra, if you see it. Now question arising is, now we are in algebra. Now we have any point P, and this point P, this point P, the position vector is xi plus yj. This point P is xi plus yj. Okay, that is same as x, and in bracket I plus y by xj. Xi plus yj is same as x, and in braces I plus y by xj. Same thing. Then magnitude of this vector is x, you can keep outside 1 square plus y by x whole square root. How it will make difference? That is the question. But if you minutely see it, there are two things I carved out of this. Xi plus yj is the vector form of any line that is connecting origin and point x comma y. Xi plus yj. If I take out x, then it has two forms now. One is called algebra and one is called vector. Algebra is x and vector form is I plus y by xj. I would reshuffle it. Now we have I plus y by xj into x. This explanation is not available anywhere else. Don't mind, please don't mind supporting us. Plus 91 is the India country code. 94831 60610 is the telephone number. 94831 60610 is the telephone number. Plus 91 is the India country code. Anyway, we have now two things, xi plus yj. We took add one vector, that is I plus y by xj, and another is x. X is x-axis and this is a vector into x. Now if I try to find the length, then I have to calculate magnitude of this vector, multiply by x, because x is not vector. The magnitude of this will be 1 square plus y by x whole square root. This into x is the net length of the line. Okay, this is the magnitude of the vector, okay, which has x as 1. If I have a vector for which x component is 1, then vector equation will be I plus y by xj. Means this vector is passing through a point that is 1 comma y by x. Actually, it is passing through a point called x comma y. Now I am saying it is passing through a point called 1 comma y by x. Whatever the length of this vector is, multiply it by x. You get same effect as x square plus y square root. Makes sense? But we divided our calculation of calculating the line length into two parts. One is vector magnitude part, which x-axis is 1, and then net x, how much x for x we want. This is called multiplication of two items is giving us a result. This is something that we are pulling towards integral calculus. Why we need integral calculus? Because for the line curve y equal to x square, if I take any point x comma y and if I take out the vector, then this vector length will not give us what we want. This line is very minute. Vector is a straight line. In that sense, if I take the vector at this point, okay, that will be tangent vector. The tangent vector will be variable at each point. It is something that I don't understand how to do, how to calculate this line length. I don't know. Okay, if it was just from how much line length we want when x equal to 0 and x equal to x. When x equal to x, it is hitting here. If it was a straight line, then I could have just said xi plus yj. Okay, anyway, but algebra, but whatever it is. Now in pseudo term with not exact solution. Okay, pseudo means what you would have done in simplest case. That is called pseudo code. Pseudo code in mathematics, generally in programming, people write pseudo code. Pseudo code means what you would have done when it was straightforward. This is called pseudo code. People, they do not understand pseudo code in programming, in computer programming. People write pseudo code. Pseudo code means a code that should be written for the very straightforward. What is straightforward? Straightforward means a straight line. Name is straight, right? If person is walking like zigzag way, rather than I think that he is walking in a straight line. A straightforward solution, if it is written in a fashion that is also called pseudocode. What is pseudocode now? Pseudocode, if it is a straight line, then it is nothing but the vector representation of the line when x-axis is 1, that is I plus y by xj, into for how much x-axis we want into x. It is exactly same as xi plus yj. Okay, this is what it is. This is the length of the vector. Now, if I have the line what we are talking on which we are trying to calculate the length, if that line is not a straight line, then it has some algebraic equation. Okay, in that sense, every moment y by x is changing. Hop, 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 hop. That is the problem. If I have x-axis and if I have a line like this, every moment y by x is same. If this is x and this is y, if this is x, this is y. What is y by x? If this is x1 and this is y1, then y1 by x1 is same as y by x. This is a straight line. So if it is a straight line, then I plus y by xj, its magnitude, this vector's magnitude into x gives us the net length. What about y by x is not constant? That is the problem. The internal of the problem is if I have x-axis, if I have x-axis, what is the inside of the problem? Inside of the problem is y equal to x square. Okay, if y equal to x square at okay, if this is x-axis, then it is y equal to x square. At every x, y is x square. So y by x is x as per the algebra. Y by x is x as per the algebra. Now, how we are trying to find the line length, that is I plus y by xj into x, or the magnitude of this vector into x. This vector magnitude is 1 plus y by x whole square in square root and then into x. Okay, this is what it is. Now, we are saying if it is a straight line, okay, so if it is a straight line, then y by x is constant. You take y by x at any moment, y by x is constant. Here, whatever is the y, here whatever is the y by x, here whatever is the y by x, it is same. But here it is not same. It looks like it is not same, means it is not a constant. That is the first difference that we are seeing. The first difference that we are seeing here is that y by x is not constant. It is dependent upon x. So if I say y by x, then here y by x is 2 when x equal to 2. Y by x is 4 when x equal to 4. Make sense? That is the main difference that between straight line and the curved line. So if we are trying to use the multiple, if we are trying to calculate the length of the section with formula, that is I plus y by xj, magnitude of it into x. This is how we are trying to calculate the length of a section. That is 1 square plus y by x whole square root into x. If I take x as 4, when I take x as 4, then y by x is 4. So is it the line length of the curve? No, certainly not. If I take x equal to 4, if I take x equal to 4, then at that point the length of the curve we are getting, that is a straight line. If I take x equal to 2, then y by x is 2. Y by x is 2. Then 1 plus 1 square plus 2 square root into 2. That is the length of the, if I take x equal to, if I take x equal to 2, if I take x equal to 2, if I take x equal to 2, then this is the point and we are getting the curve length here. Intricacies are there, right? If there is a straight line, if there is a straight line and this is the, if there is a x-axis and there is a straight line, then y by x is constant at every point. If this is x and this is y, this is y by x. If this is x1 and this is y, then this is y1 by x1. Both are same, constant number. If I take y equal to x square, then y by x here, when x equal to 4, then y by x is 4. When x equal to 2, y by x is 2. It is variable. Variable in the sense, whatever we are trying to calculate this magnitude, magnitude is 1 square plus y by x square whole square root into x. What is the length of a section of a line? from origin to origin where x equal to 0 to x equal to x. That is the original question. Now, if that is the case, then at x equal to x, go and hit the line that is y. That point is x comma y. Then calculate the position vector of that point, that is xi plus yj, and that is x square plus y square root. Okay, that is very nice solution, but that solution is not working when it is not a straight line. That is the main thing. If I take any point x comma y, it will make if I draw a straight line, it will be length of the straight line rather than the curve. What is the problem we are seeing? Because then what is the problem we are saying? For that we dissociated the equation. We what is the length of the line? Length of the line is, line section is x square plus y square root. That is the length of the vector, that is xi plus yj. Xi plus yj is the vector which connects origin and x comma y. Okay, in reverse fashion. Now problem is happening for a curved line. We cannot go with the, if I take any point x comma y from origin, if I connect a straight line, that line will give the length of the line rather than length of the curve. Okay, in that sense, why this is happening is what. Okay, so now we will break this into a multiplication problem. I'm just breaking it. Now we have the two, we have earlier we had vector that is xi plus yj. Xi plus yj, that is a vector. We can rewrite as x into I plus y by xj. I'll shuffle it and it becomes I plus y by xj, bracket closed, into x. Same thing. Now, to find the length of this vector, then we have to find the length of this vector multiplied by x, because x is not vector. Then it is square root of 1 square plus y by x whole square root into x. Now, what is y by x? We have to find. It should be a numeric value and then multiply by x, whatever x someone is taking, and then it will give the net length of the line. But problem here is y by x is not constant. Y is x square. Then y by x is x. At different x, y by x is different. In that sense, we cannot use the length of a vector is I, the length of a vector that connects point 0 comma 0 to x comma y is xi plus yj, and it is same as I plus y by xj into x. And then if I try to find the length of this vector, then one is vector, one is algebra. I have to just find the length of the vector, that is 1 square plus y by x whole square root into x. This formula will not work because y by x is different at different x. It has to be constant because this formula was derived for a straight line where y by x is constant everywhere. But here it is dependent upon x. Now we will do through two fundamental laws. One is called primitive calculus, one is called modern calculus. What modern calculus is saying? Modern calculus is saying you are trying to find out the length of a curve, right? Length of a curve is same as you cut now from x axis, x equal to 0 to x equal to x, right? Now x equal to x, cut it into infinite size. Make chopping, 100 chopping, 1000 chopping. Now at each chopping you calculate the length. Each chopping you calculate the length and add it. This is what modern calculus says. Because if you make very small chop, at that point this curve will feel like a straight line. If it is a straight line, then you can use your formula. Because your formula to calculate the length of the vector is I plus y by xj into x. That is the vector form. Length is 1 square plus y by x whole square root into x. This is your formula, right? Then use the formula for any small subsection. Chop it into many parts, n part, where n tends to infinite, and then one part, chopping part, will like a straight line. Then calculate the length of that part, then add all the n points. Okay, then it is summation I equal to 1 to n, where n section we have divided it. If n equal to 1, then there is only one section. If there is n equal to 10, then there are 10 sections. Summation I equal to 1 to n. I equal to 1 to n. Summation sign. This, this, this. I believe, I don't know what it is called. This, 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 this. This is summation sign. At the bottom right, I equal to 1, and at the top right, n, where up to n. Now add it, where one section is I plus delta y by delta x, where one section width is delta x. At any point on the x-axis, at any point x, take delta x. This part is delta x. At any point x, one section is delta x. If that is the case, then height is delta y. If this is delta x, then the height is delta y. That section, calculate the length of the vector. That vector notation is I plus delta y by delta x j and into delta x. That is your fundamental. Now if you add for I to n, if you add, then it will become like a calculus. This is modern way of calculus. Then it will become I plus dy by dxj into dx. This is what you wanted, right? Now calculate the magnitude, that is 1 square plus dy by dx whole square root into dx. This is modern calculus. Modern calculus is divide your problem into small infinite section. For one section, your curve will look like a straight line. If it is a straight line, then you have the formula, right, already. Yeah, I have the formula to calculate the length of the straight line. That is I plus y by x j into x. Then magnitude of this vector into x. Then it is I plus delta y by delta x into j into delta x. That is for one section. That is a straight line. Then now add it for all the sections. Then it is I, where now you can say, I plus delta y by delta x at the denominator, write I. For the ith section, this is another explanation. Delta y by delta x for the ith section into j, bracket close, into delta xi for the ith section, where I, now take I equal to 1, I equal to 2, I equal to 3, and you can have like I plus delta y by delta x for the I section 1 j and into delta x1 plus I plus delta y by delta x for section 2 j into delta x2. Now get the length of every section and add it. It will become 1 square plus dy by dx whole square root into dx. Now integrate it from 0 to x. You will get the result. This is modern calculus. What is primitive calculus? Primitive calculus says that if you are dividing two items and one item numerator is dependent upon denominator, then it is candidate of differentiation, not normal division. If you are multiplying two items and one item is dependent upon another item, then it is candidate of integral calculus, not normal multiplication. So what we are trying to find out, the length of a line is I plus y by xj. The length j vector into x. Length is I 1 square plus y plus x whole square root into x. This is the length. But problem here is y by x is not constant. Okay, why it is not constant? Now let's see. There are two things here. Whenever we are trying to solve something through calculus, then we see division and multiplication, because we replace division by differentiation and we replace multiplication by integral calculus only when the one part is dependent upon other in multiplication, and in division numerator is dependent upon denominator. If I say 1 square plus y by x is division, and in that sense y is dependent upon x. That's how the curve is. Now y by x is is candidate for differentiation. So we can replace blindly as dy by dx. What about if they are not dependent? Then it will also cover. Division is subset of differentiation. So that whatever you get from the division, whatever someone gets from the division, anyway, it is covered through differentiation. So it becomes now 1 square plus dy by dx whole square root into x. Now we have multiplication now. Okay, x multiplied by 1 square plus dy by dx whole square root. This part is dependent upon x. If you see closely, this part is 1 plus dy by dx. 1 plus dy by dx whole square, this term will come in x only. So whole term will come in x, then it is dependent upon x axis. Like y equal to x square. Y is actually x square. And this x square term is dependent upon x. Make sense? Similarly, the magnitude 1 plus dy by dx whole square root, full term will come in form of some function of x. Function of x means it is dependent upon x. And right side we have x, that is independent component. Dependent into independent will turn into integral calculus. Now whole will become 1 square plus dy by dx whole square root into dx. This is multiplication will turn into integration. Okay, this is long time. We will solve it and we will see area. Idea was to start area calculation, but this is how it is. So why we reach calculus is first we start with numeric, distance between origin and 4 comma 4. First we start with numeric, then we go with algebra when it is straightforward. Like line was a straight line. When algebra comes in a form of dependency and independency, then we look for the division and multiplication. Division turns into differentiation when numerator is dependent upon denominator, and multiplication turns into integral calculus when one is dependent upon other. And then we had actually the length of the curve was x. How we found the length of the line is we represented line through a vector, and then we found the magnitude of the vector. Okay, but that magnitude of the vector was not giving result only when it was a straight line. If it was a curved line, then magnitude of the vector was not giving the result. In that sense, we started thinking about breaking this into multiplication and division so that we can use calculus, because we are feeling that if it is not a straight line, then y is dependent upon x. Dependency and independency, we started getting a smell of independent algebra and dependent algebra. X axis is independent and y axis is dependent. If that is the case, then we have to think about calculus, not direct algebra. But calculus will work only when we have division and multiplication. Then only calculus will work. Then we dissociated this vector form, that is xi plus yj, into division and multiplication, so that we will get kind of division of dependent and independent, multiplication of dependent and independent. Now it became xi plus yj turned into I plus y by xj multiplied by x. Now y by x, y is numerator, x is denominator, and y is dependent upon x. I change silently into dy by dx. Now the net length of this curve is magnitude of this vector. Magnitude of this vector is magnitude of I plus dy by dxj into x. Then it becomes a square root of 1 plus dy by dx whole square root into x. Now there are two terms. One is x and one is the square root of 1 plus y square by dy by dx whole square. This square root of 1 plus dy by dx whole square, this full term is again become dependent upon x. It will come as x variable. And this dependency is dependent upon another multiplication factor x, that is x. Now we have one independent x and dependent is the square root of 1 plus dy by dx whole square. If this kind of scenario existing, then it is integral calculus. Now it turned into square root of 1 plus dy by dx whole square into dx. Now we do the integral calculus, we do this multiplication through integration, means calculating the area, and then we integrate x from